Okay, so today our lesson is called Intro to Logarithms. Now, it might seem weird to have an introduction to something you've already been working with. So far, we've used logarithms as a tool to cancel out bases so you can solve equations, and that's really, the prime reason they're there. But you can also sort of study logarithms as their own specific subject. So we're going to be going over two things today: rewriting and graphing. So rewriting a logarithm is based on what you already understand about exponents. And I briefly went over this once before last week. So an exponent has three parts: a base, a power, and then an answer. A logarithm also has three parts, and they're the same three parts. You can take these three things that you see over here: the base, which I'll do yellow, the power, which I'll do orange, and the answer, which I'll do red, and you just rearrange them into a logarithm equation. So all logarithms begin with log, except the natural log, but whatever. Okay, all logarithms have a base, b, that's the same b as you have over in the other equation. All logarithms have an argument, a, which is analogous to the answer over there in red. Then logarithmic equations have an equal sign, and the other side of the equal sign is the power, which is in orange over there. So it's the same three numbers, just rearranged with a little log abbreviation in front of it. So you're going to be asked to take something that's given like this and change it into that, and you're going to be asked to take something that's given like this and change it into that. You're just rewriting. There's nothing to simplify, nothing to solve, nothing to work out. So on this particular assignment, there really is no work to show. I know I'm kind of a stickler. Some of you got some assignments handed back saying you need to show your work. This isn't one of them. It is just darn simple. So I'm going to go ahead and start off with some of the evens here. And then, like I said, there's a second part which is going to be graphing. I'll circle back to that in a minute. So number 2 through 8, we are supposed to rewrite in exponential form. Exponential form is where there's a base, a power, and then an answer. So number 2 is already a logarithm. The base is 19, the power is 2, and then the answer is that 361. And that's it. There's nothing to do here. I mean, if you wanted to, you could grab a calculator and do 19 squared and see, does it really equal 961? And it does. But that's not the point. The point is, can you take these three components and arrange them in the proper configuration to make an exponential equation out of it? Number 4. So the base is 12. The power is the other side of the equal sign, -2. The answer is 1 over 144. And again, that's it. There's nothing to simplify, nothing to work out. That's it. Again, you could go 12 raised, oops, nope, that's wrong. Raised to the -2, you get that funky decimal, but if you hit the fraction button, there it is, 1 over 144. Now, checking yourself that way only works so long. When you get variables into it, you can't really use the calculator to make sure you're right. Of course, obviously, you are going to check yourself way down here, and so you see that answer and that answer. But the calculator really doesn't help much on these exercises. So number 6, rearrange this in exponential form. So we have these three variables. Which one is the base? Say the answer in your head. Okay, if you said z, you are correct. Which of the other two variables, x or y, is the power? And it's x, which means y is the other side of the equal sign. The argument, as it's called here, is the answer over there. Last one, number 8. What's the base? 5. What's the power? Y. And what's the answer? X. And let's check 6 and 8. Z to the x equals y. 5 to the y equals x. Those are both correct. The next set of exercises is the same thing, just the other way around. We want our answer to be in logarithmic form. That means there's a log, a base, an argument, and then the other side of the equal sign is the power. So to do number 10, I'm going to start with log. The base here is 17. The base here is 17. The answer here is 289. The argument is 289. The power is 2. The 2 goes over there. And that is it. Number 12, log. The base is 225. So you put down, So you put down 225. The answer is 15, so the argument, or the big number in the logarithm, is 15. And then the power up here, 1/2, that goes on the other side of the equal sign. I suppose you could, in a pinch, use the calculator to check yourself. I'll go back to number 10. Do log A. I'll put a 17 down here and a 289 up here, and you get 2. That's the number over there. For the next one, function log A, 225 down here, 15 up there, and 0.5. 0.5, of course, is the same thing as 1/2. So you can check yourself that way, but it's not going to help you when you start getting into variables. So checking yourself on the calculator, again, not super reliable. Number 14. So start with log. Which one of these three things is the base in that exponential equation? It is 12. What of the two remaining things is the argument? Argument starts with A. This is the answer. That starts with A right there. And then the other side of the equal sign, -3. And number 16. Log. The base is V. The answer is 3. The argument is U. And so I already checked 10 and 12 on the calculator. I can check 14 and 16 down below. So what is that? 12x and -3, v3 and u. Right, let me see if I can keep that in my short-term memory. Where am I? 14v, no, that's the different. 12x -3, v3u. Okay, so 14 and 16, check out. All right, so I said we're doing two things. We're rewriting, so that's what we just practiced, and then graphing. Graphing, I'm not going to get super into things. We are going to rely on Desmos, and I'm going to ask you to do the best, most accurate graph you can. One highlight of graphing logarithms, y equals log x. And again, logarithm is going to have a base here, so it could be any sort of a base. But these graphs do have a vertical asymptote. So again, an asymptote, it's like an imaginary line. It's not really part of the graph. I usually draw them as dotted lines. And it's a line that the graph gets really, really close to without ever touching or usually crossing. So as we go through and graph these, you can expect every single one to have a vertical asymptote. Number 18, y equals ln x plus 4 in parentheses minus 2. Remember, ln is just a logarithm. It has a base whose base is e. So y equals function ln x minus 4 in parentheses minus 2 outside parentheses. So now I want to try to graph that on my graph paper here. Can you look at this and see what is the vertical asymptote? I think it's pretty obvious that that kind of straightens out at 4. So whether you like to do it or not, I like to draw in that vertical asymptote. Looks like there's maybe a key point here that I can go to, 5, -2. That just kind of jumped out at me. You're not just supposed to know, oh, there's always going to be a key point. But it just kind of stuck in my mind that or it just visually it looked like it. Okay, there is an x-intercept of 11.389. Our graph doesn't really go out that far, so you would not be expected to draw an x-intercept on this one. But I'm going to try to approximate it anyway. Now, what you see here does not level off, and my drawing is bad. I apologize, but this arrow does go up forever. If we zoom out, it seems like it's really just level, but it does keep getting higher and higher. It's just really, really slow. You might think, well, that looks like an asymptote. But if you go far enough, it will keep going up forever and ever up to infinity. It seems ridiculous, but it happens. So there it is. Best, good faith sketch of that graph, and that's all I'm asking of you guys. Number 20. So y equals function log a. The base is 2. The argument is x minus 1. Then outside of parentheses we have a plus 5. So let's see. This one, the x-intercept is very reasonable. It's practically at 1, but not exactly at 1 because I think the vertical asymptote is 1. This will never ever cross. If you zoom in, well, it looks like I could zoom in forever. I'm just going to hit the home button. This is never going to cross that 1, that line 1. But up here, it eventually does curve. Let's see, what is that? Somewhere 2, 5. Okay, that seems very coincidental that the other point had 5, 2, and this one has 2, 5. But there we go. Again, not a perfect sketch. Actually, I think I did pretty good on that one. But, you know, just your best, whatever you can do. I'll sketch in the vertical asymptote if it helps. So for you, the vertical asymptote, the dotted line, that's optional. Do it if you think it helps you draw a better graph. Number 22, y equals function log a. I can actually type 1 divided by 2, but look what it does. It kind of messes that up. So there's a couple different ways to handle this. Of course, you know 1 divided by 2 is 0.5. I hope that's something you're familiar with. So you can just type in 0.5 there. If you really want to type in 1 over 2, oh no, parentheses don't work either. I guess you're going to have to do, well, I ruined that. Okay, I guess you're going to have to do the 0.5 decimal. Oh my goodness, I'm doing everything wrong. Start over. Y equals function log a 0.5 x minus 1 plus 4. So now, having a base that's a fraction, 1/2, or a 0.5, instead of making a graph that looks kind of like this, it actually flips it upside down. Now, can you look at that and tell what the vertical asymptote is? I think it should be pretty obvious that it's at 1. If I scroll up, it gets really, really close to 1 without ever crossing it. And is there a key point or two that I can graph? 2, 3, 3, 3, 3, 3. Oops. So right about there, I have my vertical asymptote right here. The x-intercept, well, that's way out there, it's 17 something. So I'm just going to come down like this, curve through there, and then go kind of like that. That's maybe not that great, but we'll call it good enough. And good enough is, you know, kind of what I'm looking for here. Of course, when you're done, you can scroll down and see, okay, do my graphs kind of look more or less like what they're supposed to, and critique yourself there. If you're way off, like if you drew number 22 like this, I mean, it's upside down, and you check yourself, that's when you'd go back and redo. But so yeah, that's pretty much it. Just kind of an introductory day, not a lot of heavy lifting here. As far as rewriting, consult the notes, look at the examples. As far as graphing, just use Desmos. Keep in mind there is an asymptote, and do your best to graph those. If you have any questions, use comments or email me. Otherwise, I hope you find this assignment to be very doable. See you later.